And so sometimes we're not just interested in the interest earned over time or the interest paid over time, but we're really interested in the amount, the total amount of an account, right? So if you deposit some money into a savings account, you're not really interested in just the interest, but really how much money you have in general or overall, okay? And we looked at that in the previous example where we talked about the future value of an account. Well, we're going to define a new variable. The variable is going to be A. That's going to be our future value. And I think we use the letter A for amount, but I don't know that for fact. That's what I always think of when I see the letter A. So A is the future value. So what you want to do is you take A, and you're basically taking the principal, the original principal, and adding in the interest that's calculated. Now we know the interest is the principal times rate times time. And so if we make a substitution there, replace I with something it's equal to, we get this formula. A equals P plus PRT. Now, what's interesting, in algebra we have a property called greatest common factor. You have two terms here and both of them have a P involved. And so we can sort of use the distributive property in reverse to what we call factor out the P. And so if I did that, I have P times 1 plus RT. And so you could undo what I just did by using the distributive property. P times 1 is P, P times RT is PRT, okay? So I'm really reversing the distributive property there. Now this new formula, and this is our final version of the future value formula, is useful because now I can just take the present value, the rate, and the time. I'm sorry, not the present value. The principal, the rate, and the time, plug them in, and I did one calculation, gives me the future value, okay? So for instance, if I wanted to deposit, let's say $12,000 in an account that's earning 0.75% annual interest over let's go with a 3-year period. Okay, 3 years. Then you just plug those values into this formula. The 1 represents the original 100% of the principal. The RT represents the rate times time, which is the portion of the principal that you're earning in interest, okay, over that time period. So A is equal to 12,000 times 1 plus RT. Of course, R has to be converted into a decimal, so we move the decimal point 2 places left, 0.0075 times 3. Okay, need a double parenthesis there. And so 0.0075 times 3 plus 1, you could really just put all of this into your calculator if you want. So I put 12,000 parenthesis 1 plus 0.0075 times 3 parenthesis. If you want to see that, I don't know if you can see that real well, but there it is. Okay, and I hit enter. Oops, I didn't show you the enter. 12,270. So the amount is $12,270 that you would be able to receive after a 3-year period. Okay, so this is not just the interest calculated. The interest calculated is just the 0.0075 times 3 times 12,000. But by adding the 1 in there, that will put the original principal back in as well. So we've got the original principal of 12,000, and then this would end up being $270 of interest over that 3-year period. Now, what's nice about this formula is not just that I can calculate the future value, but let's say I had a goal in mind. Let's say over the course of the next 2 years, I wanted to put some money away, or I wanted to put some money away now, so that over the course of the next 2 years, I could buy a new car, okay? And let's say the car was going to be worth, was going to cost me, $15,000, let's say. I can use this formula to find how much I need to deposit if I know the interest rate. Okay. So let's say I know my car is going to be worth $15,000. So that's what I want to purchase 2 years down the road. The interest rate, let's say, is, say you get a, 3.5% interest rate. Okay. On this loan, or no, on this deposit. You're depositing this money. Sorry, confusing myself here. Did I say loan earlier? I want to deposit. I want to deposit money to try to get back $15,000, and I want this over a 2-year period. Okay, so all we do is we put these in. Now the $15,000 is what we want to get in the end. That's our future value. So I put that in for A. Okay, so 15,000 equals P times 1 plus 0.035 times 2. Okay, so I plug everything in that I know, and now if I solve that equation for P, I'm going to get the amount I need to invest to make that happen. It's going to be something less than 15,000, 14,000 something, or 13,000 something. But it's going to be less than the 15,000 that I need. Okay. So to solve this, I'm going to evaluate the stuff in the parentheses there, and 1 plus 0.035 times 2 is 1.07. So we'd have 15. Oops. Let's write legibly here. 15,000 equals P times 1.07. Now to solve for P, you do the opposite operation. Instead of multiply, you divide. So we divide both sides by 1.07. Of course, we do that because we want to do the same thing to both sides of an equation to keep it balanced out. Okay. And if I do that calculation, 15,000 divided by 1.07, and of course this is not going to come out evenly, so we're going to have to round at some point. My value that I get here for principal is $14,018, and if I round it to the nearest penny, that's 69 cents. Okay. That round is 6915 or something, so it rounds down to 69 cents. So you would have to invest just over $14,000, $14,018.69, in order to have the $15,000 needed at the end of that year, 2-year period, to earn enough interest to make that happen. Okay, so we can just solve this equation. Now, it may be the case that you have a certain amount, you can know the principal, you know what you need, but you don't know the interest rate. Sorry, principal, what you need, and you don't know the interest rate. Or maybe you don't know how long to keep it in. You can always solve for any of these variables that are unknown. Okay, so maybe in another example, whoops. Let's say I knew everything except the time. Alright, so let's say you needed to take out you needed to have, or you're starting out with $10,000, and you want to end up with $15,000. So you want your $10,000 to grow to $15,000, and you don't know how long that's going to take, but you know the interest rate. Maybe the interest rate is 2.5%. Okay, so you know you can invest that money at 2.5%, and you want the $10,000 to grow to $15,000. You don't know how long that's going to take. Well, you can use this formula. You plug in the A is 15,000. The P is 10,000. The 1 stays. The R is your 0.025. Of course, move the decimal twice to the left. And the time is unknown. We just leave a T in there. Okay? Whatever the unknown value is just gets left as a variable. And so in this situation, you want to solve for T. Well, that's a little bit harder to do, but it's still doable. The first thing I would do is when we solve an equation for a variable, we work with the things that are farthest away from that variable and then work our way closer. And so I would start with the 10,000. Now the 10,000 is being multiplied here. If I wanted to get rid of that 10,000, I would divide both sides by 10,000. And that will cancel the 10,000 on the right. Okay, so we're going to be doing some solving equations. 15,000 over 10,000 is actually 1.5. If you cancel out your zeros and move your decimal appropriately, it's 1.5. And that would equal 1 plus 0.025t. I want to then get rid of the 1, so I'm going to subtract the 1 from both sides. Take it over here, that's 0.5. Right, 1.5 minus 1 is 0.5, is equal to 0.025t. And then I'm going to divide out by the 0.025 because I'm multiplying the t by it. Okay, so divide out by 0.025. That'll cancel on the right. And so I do that calculation, it's going to be something, it's going to have a 2 in it. So 0.5 divided by 0.025, 20. There it is. So it's going to take, what, 20 years, right? So you will need 20 years to reach the goal. You know, this is a long-term investment, right? 20 years long-term down the road, but that's a reasonable amount if you wanted to say, invest some money if maybe you're pregnant and having a baby and you want to invest some money for their college fund, right? 20 years down the road is exactly, well, close to what you would want to have. So, maybe you invest $10,000 and you want it to grow to 15,000 by the end of that time period, and it works out nicely that way. So those are just some things that, some practical examples, ways that you can use the simple interest calculation. Now the next topic we're going to talk about is more of what you'll actually see in a bank. It's called compound interest. We'll get into that in the next few videos.